All right, guys. Good afternoon, everyone. Hope you guys had a great session so far and enjoying the build. Yeah. All right. I'm Apurva Joshi. I go by AJ. I'm one of the program managers for Azure App Service team, and I'm hoping that most of you are familiar with what Azure App Service is. If not, you learn a little bit about it today. How many of you are here because of the title? Like it worked, right? Somebody told me it was the best title of the whole event, so I was flattered, but it's pretty good, yes. And the rest of you probably are here to learn what this service is all about, right? And the containers in Azure App Services, they are like peanut butter and chocolate. They just go well together, right? They're just made for each other, and we'll know. Today we'll try and go over the service and see why we think this way. Okay. With that said, there's a little bit of introduction about the service to those who don't know or are not familiar with it. Azure App Service is about 6 years old. We started with a product called Websites. It's now rebranded as a Web Apps, one of our biggest workload. We do mobile apps, API apps, and functions, the serverless, right? One of the biggest things that we have out so far. And that reminds me of a little story. You know, I like to tell little stories every now and then. And this was, I was preparing for a pre-build day for Container Fest and serverless, and I was having a lunch with one of my developers or dev lead for functions, you know, and it was a philosophical conversation about our kids, like how they're learning how to code in a school, and, you know, hey, when they grow up, how they're going to use their coding skills to supplement what they're doing. And he was convinced that, yes, they all would be coding in serverless. And, you know, that's what the future is. And you know, I kind of agreed with him in a sense because it reminded me of an incident with my 11-year-old, and I'll tell you a little bit about him more when we get into how he's using this service, where I wanted to show him off one of the coolest features of Azure App Service is like the scale, the instant scale, the auto scale, like going from 1 to 10 instance, like with a slider, and bam, it works. So I make him sit next to me, and I move the slider from 1 to 10 and hit save, and I'm watching it, thinking 1, 2, 3, 30. It took about 30 seconds to get to 10 instances, and I'm hoping he's going to be super excited. I got to do 30 computers in 10 computers in 30 seconds, and his reaction was like, wow, that's slow, right? And at that point, I was convinced that, yes, Paul was right. He's going to be coding in serverless. But until that happens, this is the gold rush, man. The containers are the prime commodity of the gold rush. That's what's going to pay the mortgage, and that's what's going to pay for his tuition to learn how to code in serverless. So you all are in the right room. And thank you for that. All right, with that, let's go look at some of the numbers about our service. We're one of the few services in Azure who are proud to share these numbers publicly. We report them to board and SEC in a sense, and this just goes to show not the strength and the power of the service and how large the service is, but it goes to prove that any bet that we make with the service, whether it's the web apps on Linux or container apps or serverless or function, it is here to stay. It is built on a fundamentally core or a sound infrastructure that has been around for 6 years, where we're serving more than 400,000 active customers. We're not dependent on a few customers to run the service. More than 2 million apps are hosted, 15 billion requests per day, right? It's something we're really, really proud of, and it's a number that we watch every single day. 380,000 plus cores, K cores, customer growth 4x, 5x traffic growth, and knock on wood, the functions will take us to the next level, and the app service and containers will too. Okay, so what are we going to talk about today? It is branded as web app on Linux. Just FYI, and I'm gonna put this out as my saving grace. If none of my demo works, it is still in public preview, and but it's a pretty solid service. So we'll hopefully have a good demo. So, how do we use this service today? There are a couple of ways to do it. Either you can bring your own container, tell us where the container is, and we'll deploy for you, and we'll give you the benefit of all the Azure App Service offering. Or you can choose one of our blessed images or baked-in images, like what we call. They're also, again, containers, and just point us to your code, and we'll run it from that point on. Okay, why are we building this service? I'm going to go over a bunch of bullet points, why are we building this, and then I'll tell you a real reason why we're building this as well. Okay, so here are some marketing points why we're doing this, and it's actually true. This has been one of the top customer asks, right? Since the app service was launched, every customer kept on asking us, saying, hey, when can I run my web apps on Linux? You support Node on Windows is great, PHP on Windows is great, Ruby, we cannot tell you like, hey, you don't go run Ruby on Windows, right? It would set it up for the disaster, right? The other reason was like, hey, Microsoft loves Linux. And every 3 VMs in Azure runs on Linux, right? Now, who doesn't agree to this yet? There's nobody? Come on, there has to be someone. There you go. I got a cup for you that you should collect that actually says, sorry, Microsoft loves Linux. So every time you have a coffee, it will remind you, yes, it is true. We do love Linux. What is it?
There's no Visual Studio for Linux, and there's no .NET GUI apps for
That's a good feedback, and we'll get you a new cup for that next build. All right. What is it? Yes. Again, Ruby on Rails is a great example. Customers were asking for a stack that would run perfect and super fast and really, really well on non-Windows environment. Better tooling support for framework like PHP, Node.js, Python, etc., right? Docker is really popular. This is how we build microservices, right? It's a paradigm shift. It's a gold rush. We will be fooled if not be part of it, right? So we wanted to support that paradigm. We wanted to support the customer base who wants to embrace this. Finally, bring all the years worth of past investments that we made, the CI/CD, the slots, the autoscales, and the diagnostics, the custom domain, and everything to the Linux and Docker community, right? It would be not fair if we just kept all those features running on Azure App Service on Windows and, just not entertain the other scenarios that our customers are asking for. These are all real reasons, great reasons. There's a truth to another reason, and my dev leader Nazim's here, and he will attest to it. He basically will tell you it happened by mistake as well. We wanted to support Linux. We made a bet on Docker, and hey, container works. Let's do containers for app service, right? And well, that's his story from a dev side. The PM story is this, and this is truth. All right, let's get into the demo, right? I like to show the service off in a variety of ways today, if the demo gods support. And right before the session started, I got some news which is making me a little shaky, but we'll see. If it doesn't work, hey, the service is in preview. All right, let's start with a simple bread and butter scenario for Azure App Service, which is GitHub, right? So what we're gonna do here is go ahead and create a new web app on Linux. How you do it, click on plus, web and mobile, and you're gonna see this nice little icon that we need to change with Linux on it, is in preview. The experience room is exactly the same, right? So what I'm gonna do, I'm gonna go ahead and create a Node application. Let's call it Node for build. And I will use the existing resource group. Great. Yes, this is the sign that the ARM's most likely not behaving well. Okay. Fair enough. Okay, it came up. That's great. So here's the Node for build. It's my app name. It's available. I'm going to put it in this resource group. I'm going to go ahead and select the app service plan, which is exactly the same concept as the app service. I can create new and then select a bunch of pricings here. You'll notice the free and shared is missing, and you'll know why in a little bit when I get into the architecture. It is intentional. And we do plan to support free at some point, but there is no ETA. But right now, it's all dedicated, but you get 50% discount because it's in preview, right? So instead of trying to create the new one, I'm going to go ahead and try and use an existing one. And for the first time ever, and I'm going to tell you that I've not been practicing for this for sure, because I'm going to pick an app service plan that matches with the name of the site. So, all right, here's the distinguishing, right? So here's you can choose whether I want a built-in image or built-in container with the best runtime that we support and maintain for a long term. You can choose different version of Node, PHP, .NET Core, Ruby. We're committed to keep on maintaining this and add more as we move forward. But our hope is that people will actually move towards bringing their own containers, right? So we right now work great with Docker Hub and private registries and ACR and things like that. We'll get to it in a demo part. Right now we'll use node 4.5 blessed. Okay, I'm going to go ahead and pin this. And this should go ahead and create a web app when the ARM starts behaving well for me. While that's happening, I'm going to go ahead and go to the, okay, sorry. Come on. Yes, it's happening. It's slow. All right, so it's creating. Hopefully this will finish. And if it's not finishing, I'll probably go to the one that is pre-created real quick, which is node 4 build backup. Convenient. Yes. If it does create, we'll get a pop-up that it created, right? So here's the same application that I created, pre-created. Here's the, okay, this one succeeded. So let's just go to that so it doesn't feel like I'm cheating. All right, here. Even though it's slow, we'll live with it, right? Okay, here, the web app has been created. If I were to browse to the web app, it should go ahead and download the node 4.5 container from our app service Docker account onto the VM, provision the VM, start the container, and basically browse. You are able to browse to the page when it comes up. And yes, there's a network error. What in the meanwhile, while this is trying to come up, I'm going to go ahead and show you how do you use the existing features of the Azure App Service, which we supported and announced the support for today, is to create a deployment slots, right? So I'm going to go ahead and add a slot to the app that I created. I'm going to call a stage app. Again, this is not your web app. It's a container that we're trying to get. I'm going to replicate the settings and say OK. And this is trying to create the web app slot for this. While it's creating, let me see, this page came up where it went away. So this is the default page for Node.js application, baked-in container, 4.5. You can see the site name is this, and you can learn about the value, whatnot, right? We go here. This stage slot has been created. It's exact same thing as the previous container, but what we're going to do in this one is I'm going to go ahead and set up a Git. And we're going to start our company after disaster we had with Snapchat yesterday and create an application, a chat application that uses WebSockets, right? And this is the purpose of this demo is to also show you not the slot feature, but we do support WebSockets too. So I'm trying to connect or mapping my GitHub to the stage slot. Once it is authenticated, it pulls out all my repo. I'm going to go ahead and select the node application, which is a chat application, get it from master. I don't want to perf test. I'm going to say, OK. Now, what this is doing right now is just setting up the CI, pulling the code from a GitHub, deploying to a stage slot, and having me an opportunity to test the application before we swap it to the production. So while that's happening, it takes a little bit. Right now, again, it's in preview, and we're committed to fix it. Yes? OK. While that's happening, let me go ahead and show you the Docker container. Again, it's a Node 4.5, which we replicated the app setting from the parent site. I could always choose to point this state slot to a Docker Hub or somewhere else, and then work from that point on. While that's happening, let me just go ahead and back to the deployment options. OK, the deployment, set up the GitHub file, you pull the repo, the site's up and running. It should be up and running. If I were to browse to it, it should be a nice little chat application with the URL that is on the slot site. So you see it's a stage slot now. The parent is just a simple app. The slot is what my application is. I'm going to go ahead and say my name. We can probably open up another instance just to make sure that this is actually working. And we'll say build. OK, build is sending me a message. Demos are working. And I'm getting the message. Just to show you a preview, this is supports WebSockets. Let's just look at this and hit a refresh. And you'll see, yes, it's one-on-one request. And in the frame, if I start typing now, yeah, Scott, perfect. There's somebody in the audience that's doing it. OK, great. All right, so you can start seeing the WebSockets working, right? Right off the bat. No settings needed. Great. I like it. All right. Once this is looking good, that everything's working, right? We're ready to ship our company or the software. I'm going to go ahead and do a swap. So right now we're in a stage. I'm going to click on the button and say swap. Now we're swapping stage to production. It looks for any changes, like, hey, do you have a different app settings? Do you want to make sure if there's a different app setting between slots and a prod, like a different different database or whatever, it will give me the warning before I swap. It's a simple app. There are no app settings. We're good to go. I'm going to go ahead and say OK. And once the swap is completed, we should be able to see that our stage went to production, the application is live and up and running. All these happen within a few minutes while not worrying about how do you stage up different environments and all those feature set from that point on. While the swap is in progress, I do want to show you one thing real quick, which is how many of you are aware of Kudu on app services? Great, right? So everybody knows Kudu gives you access to a command prompt to an instance where you can do limited number of things, right? Okay, so swap happened, I guess. Now if I do refresh, real quick, you see, now this is the slide, and if I go to the prod should have the Snapchat application. Great, so it's working great. What I want to show you real quick is go back here to this, and let's go to our Kudu site. Okay, great. .scm, and it should single sign me onto this. And I'm about to show you a feature that is really favorite to me. There's a bash that you can do into the container, but you can do SSH into the container now, right? So with Linux VMs, you can SSH into your container apps and run SSH commands and do the tracing and whatnot. So you not only get a benefit of a PASI features, but now you are inside your container app and actually SSH into it and do the things that you're used to with your Linux VMs in general. Just to make sure and tell you this really works, I'm going to run one of the popular commands, top dead. It works. That's the point, right? So again, this is not available for Windows. You do SSH with Linux, web app on Linux and containers. So it is very powerful in a sense. It's just not a PASI way to do it. All right, so this demo worked. We can move on to the slides and do a bit of more marketing. Target customers, who are we building this for, right? Again, people will come and ask, okay, well, there's so many container stories across the Azure, outside of Azure. Everybody's trying to do a solution or two, right? And everybody has a story to tell. And so we do, right? It is like I said, it's a gold rush. Everybody's trying to figure out the right way or build sort of a PaaS, in a sense, where you manage your containers much easily. So target audience is the ones that is bread and butter for app services who wants to rapidly build, deploy, manage powerful container apps that just easily scale, right? They don't want to worry about any quirks that comes with learning about underlying VMs or containers infrastructure or like orchestration. They don't want to worry about any of that, right? Here's my container, just go host it, give me all the scales and management of the container, and if the container goes down, take care of it and everything. I don't want to learn about any of the orchestration. That's the customer base. And typically that's a customer base that wants to crawl, walk, and run into a full container-based architecture. Everybody wants to have a fit or learn about it or want to containerize their application, but not sure if the right way to get the whole enchilada and then move it to one big orchestration system. They want to take a web app or two and say, hey, what would you like to containerize this application? And we'll talk about one of the customers who actually done that at the end of a session and how they learned this within a week and how they absolutely love it to go that route. Again, Azure App Service on Linux and containers, there's a customer set who's been asking for this. We want to run this on Linux. We want to run this for containers. And they are the ones we're targeting as of today. OK, let's go back to a demo, another one. So, of course, staying true to who we are, it would not be fair if we did not support gallery apps, right? App Services allows a nice marketplace where we have a bunch of gallery apps set up for people to get their application up and running. And one of the most popular gallery app is a WordPress, right? So we have also announced WordPress on Linux gallery app. When you search for that in Marketplace, that's the first thing that comes. Again, it's in preview. Everything that I talk about, it will most likely be in preview today. And let's call this WordPress on Linux for build. Okay, we go back to the resource group that is existing, so I can go back and delete the resource group without getting charged for all these VMs that I'm creating and free up the capacity for all of you guys. Over here, you'll see 3 options. You support MySQL in-app. If you want to put MySQL inside your container and a WordPress in the same place, great. You can choose to use our service that we announced today, which is, well, not today, yesterday, Azure Database for MySQL. Orcus is a code name, Postgres for MySQL. I'm going to use that for now. I'm going to go ahead and choose an app service plan that I pre-created. When that loads up real quick. Okay, while that's happening, I'm going to go and switch here to show you the options of the database that you create, right? So if you want to learn about all the options that this database server or MySQL service creates, there's another session, I guess, that happened yesterday. Maybe you can see the recording for that. And when ARM comes up, this would work. While that's happening, let me switch back to my backup site. All right, so I'm going to go here. Well, it won't let me do it here. Okay, so I'm just going to go ahead and create this simple database using Orcus. Keep everything else same. Okay. Whoops. Okay. Right. Yeah, I think ARM's having probably sort of issue where the service is a little slow in a sense where the API calls are going, but it's good. It came up here. Okay, I'm just going to keep here. I'm going to use the WordPress on Linux for build app service plan. I'm going to go ahead and say create. This one takes a little time because it has to go download the template, copy the files over, and then configure the database, and etc. While it's happening and doing its thing, I'm going to go back to slides and start talking about a few things. How we build things internally. So how many of you are aware of the architecture for Azure App Service? Okay, very few. Who are aware, I will go over the refresher, but who are not will hopefully learn something new. So this is basically a scale unit of the Azure App Service. When we say scale unit, it is a one single stamp or a deployment of 1,100 VMs in a one given region. So when you go to portal and select my new web app in a West US, you're probably getting the web apps deployed into, say, West Bay 001, which is supposed to be West US 001 or 003 stamp number or whatever, and it gets deployed in one of these workers, whether it's Windows or Linux out there. We got about close to 500,000 plus stamps across the world, all the regions, and this scale unit just represents one specific stamp of 1,100 VMs, right? We have a bunch of front-end load balancer, which is what makes our service very unique. So every time the new requests are coming in, we try and find out where this web app is hosted, and then direct those requests to your instance of your web app. It can be a single, it can be 10, and these are the ones that are basically taking the hit of redirecting and provisioning your site and everything without you realizing how that whole scale in, scale out works. There's a publisher role, which is basically allows you to publish your content. Every time you use FTP or web deploy or Kudu, this content basically, or those calls basically go from a publisher, and the content gets deployed to roles that we call as a file server, which are shared instances with the proprietary role where you have which are backed by Azure storage. So when your VM starts, we basically give you a slice of a blob storage that is basically mounted as a drive onto one of these file servers, and all your workers are basically pointed to saying, hey, the content is on this file server. So this is exactly why when you go from 1 to 10, your content is available like this within a few seconds and not minutes and things along those lines that you require for other services. So when you do publishing, the call and the content never goes to the worker. It directly goes to the file server in a common shared. So as soon as you publish, it's available to all the instances that you have within your service. We also have a data cache and a database that has your configuration for your site runtime and whatnot. We have stamps with Linux workers and Windows workers. But in short, this is what the architecture. I can probably spend another 30 minutes going into details, and then it will not be like peanut butter chocolate. So with that, we'll just move on to see if the WordPress got created. Yeah, it is still deploying. The ARM's pretty slow, so we're going to just skip that part, and you have to just trust me that it worked, because the last demo worked. but I will show you the backup site. All right, yes, it is the WordPress running, and then, basically going against that database, and then you can browse to it and whatnot. Okay, let's move on to my favorite demo. So bringing back, now, let's go back and see the scenario of how do you bring your containers to the Azure App Service, right? So I'm going to go back here to the portal. I'm going to say create new. Same way, web and mobile. Web app on Linux. Pokemon 4 build. Now, before we go any further on this, let me go back to the story that I told you about my boy. I was showing him 1 to 10, and he goes it's very, very slow. He's actually one of the users of my service because there's this game that he's really addicted to called Pokemon Showdown, right? And he used to keep on playing that with his friends on public servers and whatnot, and then he found a way to have a container hosted to host his own server running and invite his own friends and a community people to come together and play a game in a limited situation, right? So, and I'll show you how it is easy to set up that Pokemon Showdown server, and we'll go to his server. Probably will not. He's in his school, so he won't be playing that, but we'll get to see how others are using that real quick. So I'm going to go ahead and use this. And here's what he did. He basically go create a new web app, build 2017. We'll just go ahead and select an app service plan. Come on, yeah, all right, ARM seems to be doing great. I'm gonna pick Pokemon 4 build. All right, over here, we're gonna point to the image that the person is maintaining. Pokemon, it's Azure Pokemon Showdown. I can specify a startup file if my Docker file has any startup. If not, then I'm just going to click on that, and it's going to go ahead and basically point me to that container from the Docker Hub, pull the container down, and then run this server onto web app on Linux when it's done deploying. While this is doing this thing, let's go ahead and see another set of people who are really hooked to this game and are actually running on this thing. This is a server that is hosted by my developers who are responsible for working on the service and shipping it. This is the biggest reason why not GA yet, because the dev lead is here, PM is here, and this is what these kids are doing right now, is they're probably playing Pokemon Showdown, right? But if you were to be playing Pokemon Showdown, you might as well do it on your platform and make it super, super good, right? So these are the guys, we can go into some of the battles and see what they're trying to do, but you get an idea, right? Oh, here's Nazim. He's probably sitting here and playing too, right? So okay, there you go. The dev lead's also playing this Pokemon Showdown. But the idea is right here. This is what makes it very, very appealing to run container apps on web apps on Azure App Service. It's really simple, right? You just have your container somewhere, and a kid like 11-year-old or all these kids that are working on this product, they're able to set up something this complex that probably would have taken a long, long time to deploy. Within a few seconds, right here. This is a new deployment that we just did. It pulled the container down from the Docker Hub, deployed on Azure App Service on one of those VMs that you saw, started the container, routed the request. All these things happened within less than a minute. And look at the startup time and things along those lines. So this is the benefit, or one of the benefits that we bring along. All right. Moving on again to some of the announcements. Okay, this morning or yesterday we announced support for site slots and swap that we saw today. We announced support for autoscale. If we have time, we'll probably go through the demo for that too. But basically, you can set up the autoscale based on CPU, memory, disk queue length. Testing in production works, right? So now if you have slots, multiple slots that you created, and you want to route X% of your traffic to say stage or QA, or a beta site that you created, right? You can basically click, and set up the testing in production, and we'll take care of routing. Those front ends that I talked about, they will take care of the routing of requests to X number of instances or slots that you chose. Always on, again, a feature that will keep on continuously pinging your container, so container will never go down or not go down, but won't have a cold start because it's always up and running. The CI/CD with Docker Hub, and we'll, time permits, we'll see that in a little bit too. SSH into container. We have continuous delivery using VSTS. And this is a key scenario because there are a bunch of customers who ask, how do I get started Dockerizing my application, right? And VSTS will play a big role in that. You say, here's my base image of .NET Core or Python or PHP. Here's my code in GitHub or VSTS. And then VSTS will combine them together, create the build for you, deploy on Azure App Service, and you get it from that point on. So your devs are continuously checking code into GitHub. Your base image stays where it is. Everything gets combined into one single container with your code in it and gets deployed into Azure App Service. We'll see that if we have the time as well. WordPress, wildcard support, auto port detection, and the new region that we started supporting this morning is Australia. We'll probably open it up in a couple of days because it's a geofenced. Okay, let's move on to a scenario where how do you Dockerize your .NET application, or how do you Dockerize your regular application? And I want to show you some of the toolings that the VS team has built with us. So I'm going to go ahead and create a simple, really, really simple .NET Core application. Here, it's called Build 2017 Core. I'm going to go ahead and say OK. And it tells me it's an empty web application. Right here, you see there's a support for enable Docker support. I can choose that right away, or I'm just going to go ahead and say, create the project first, and I'll show you from the IDE how do you Dockerize the application and how that works. Okay, it'll take a little bit. It's creating a simple .NET Core application. Here's the solution for that. I'm going to go ahead and right-click when it starts responding. Click on Add, and say Docker support. I have Docker tools for Windows pre-installed, but if you have Visual Studio 2017, it has all the Docker tools and everything baked into it. So right now, it added basically a Docker support. And the way I know it added Docker support, because you can see the Docker compose file and actual Docker file that has been created. If I click on the Docker file, it tells me, OK, yes, use the ASP.NET Core 1.1 image from Microsoft, which is the Azure Container Registry, right? The source working directory is going to be app folder, expose the port 80 because that's where the request is going to come from, copy the content from here, and here's the entry point. Great. So I've just Dockerized my application by right-click, add Docker support. I'm going to go ahead and publish. And when you right-click and publish the application, some of the options to publish into containers is right now only Azure App Service, which is in preview. That makes me happy, right? Good. So select that. Go ahead and say publish. And I'm pre-logged in, but if you're not, it's probably going to have you log in, and it will fill out all the information. Here's the app that I want to create. Here's the subscription ID. Here's the resource group, whatever that is. Then the container registry that you can create new or use the existing one. And this is basically an ACR registry. I'm going to go ahead and say create. And at this point, it's going to use my existing ACR registry. It's going to take this application, Dockerize it, and push it to the ACR, and then deploy that container onto this web app that we created, Build 2017 Core or whatever. So it has the whole pipeline set up, at least from the Visual Studio. All right, so it is preparing that profile, and in a little bit you'll start seeing it does the publishing. All right, the build started. Okay, it is build, blah, blah. Yes. As you can see, the site has been already created. It's using the publishing profile for that site. Build completed. Now this is where it's sending the registry, the Docker file, to the ACR one at a time. Yes, these are the volume mounts. And once that's done, it should open up the IE and help us browse to the application that is up and running. If not, then I'm going to click on it manually. Okay, this is the time we should try and get the download the container from the ACR, deploy to the Azure web app, and then it should have the .NET Core application up and running. All right, while that's happening, I'm going to go back to the slide and see what we're going to talk about next, okay? Yeah, it shouldn't take this long. There we go. Both open up at the same time. Great. The one manual and one Visual Studio open up automatically. So this is your .NET Core application that we just Dockerized. Push the image to ACR, publish to the Azure web app, and it's up and running in a Dockerized way. If you were to go to the settings for this web app and look at the Docker settings, you will see ACR registry setup. Let me see if I can show you that real quick. Okay, here is that. Oops, bad idea. Okay, let me see if it created here. That's the guy. Okay, well, come on. Yes, ARM sometimes it's hello. Anybody there? Yes, right here. Okay, if I go look at the container, yes, you see this is using private registry. This is my password, is this thing. Here's the ACR, that's the name. And it kept on adding the tag to it optionally every time the new bill comes in, and you get an idea, right? So, fantastic. Okay, how are we doing on time? We've got 24 minutes, good. Okay, I'm gonna skip over, not skip over, I'll briefly talk about the internals of how the Linux worker does its magic, how these guys sitting here, Nazim and team, actually coded this whole thing and how it worked, right? So we have a small component inside your worker that we call as a proxy that takes the incoming request and then basically sends it to our custom orchestrator that is running inside your VM to tell, hey, here's the container this guy wants us to start, call Docker run, and point to the path of the container. And that will just basically go ahead and start up your container. And the SCM container that you see, that is the one that we start up automatically, which is the kudu one, which is really the SSH. And we put them both into a single bridge, which is Docker security isolation. If you're running a second web app inside the same app service plan, it goes into bridge 2. Third is going to bridge 3 and 4. Now, obviously, if we wanted to give you free offering and a share offering, we would have to deploy all these random customers, or not customer users, applications onto a single VM to do multi-hosting, which we don't want to do. I don't think anybody in the market does that today because of the security isolation that you get by default by Docker. Might not be that soundproof, right? So the only applications that are working on the workers that you have are your own, right? So the only person that you are under bridge 1, bridge 2, they're all your own applications. There is no multi-hosting at this point, right? And hence, we only support the dedicated offering. But you get an idea, right? You basically bring your Docker container, you run into this, and then we mount the persistent file share with a symlink of wherever your Docker content is, and we take it from there. If you were to scale the Linux worker to 10, 15 instances, it still remains the same because the site content is persistent, and it will work regardless, right? So it's just the new app service plans are running those multiple instances. Okay. This is a demo that I want to show you how we just set up turn the .NET Core application into Docker. I want to show you how you set up a continuous delivery using VSTS integration with Azure App Service web app, right? So I'm going to go ahead and create the new web app, web and mobile, this. And so we did Node, we did PHP with this, so we did ASP.NET Core. We'll do Python in this one, right? So Python for build, right? And I'm going to use an existing resource group again, the build 2017. Of course, I want to go ahead and use an existing app service plan, which I have conveniently named Python for build. Here, okay. Again, and we're going to bring the container from my Docker Hub, which is here, and I think it's called Python Flask tag 1.3. Let me just make sure that that's exactly what it is. Here's the container. You can look at the Docker file for that. And tags, the latest one is 2, but we can use a different ones. Okay, I'm going to go back. Okay. I'm going to just do 2 in a sense. Where does it go? Right here. Okay. Okay, we'll validate that, and then basically we'll try and deploy the Python image onto this application. Right, while that's happening, I want to show you that my GitHub code is basically, is right here on local Git. There's a GitHub code for that into my GitHub account. So right here, this is where the Flask application is, simple hello world. Okay, while this has been deployed, and it's trying to come up, I'm gonna go ahead and say browse to it, just to make sure I put the right tag and it's working. If not, then we'll probably go ahead and change the tag for that. Yeah, it shouldn't take this long, so it's most likely a wrong tag. Anyways, while this is happening, what I want to show you is I'm going to set up the continuous delivery for this. So I click on the continuous delivery as it is in preview. Come on, come on, come on, come on. Okay, so yes, this page came up. It downloaded the image. It says, hey, hello, Seattle is running Flask using Python on Linux web app. I'm going to set up the CD for this using VSTS. I'm going to click on configure. And you'll notice now it's going to figure out automatically that, hey, this image is using from Docker Hub. Ask me for my username and password. If it was ACR, it will pick that from there. And I'm going to say OK, and say it's asking me where is your code coming from, right? I'm going to say either VSTS or GitHub. This one is in GitHub, so I'm going to go ahead and say GitHub. It should log me into the GitHub, and then I will be able to choose one of the repos. When that comes up, in a little bit, yes. All right, there it is. And it automatically detects a Flask application, and it just points to the repo Flask. No, I'm just kidding. That's the last one I tried. That's why it said that Flask. It's not that smart yet, but yes. So I'm choosing the Flask one. Go to the master branch. That's my Docker. There's a Docker file to it. I'm going to say OK. I'll use an existing team services. Let's use VSTS for build. It's loading. First project, yes. Come on. OK. All right. So this is now going to go ahead and set up the CD with the image from Docker Hub, code coming from a GitHub. Build the image, push it to VSTS. VSTS will trigger a build. It will deploy onto this site, and by doing that release. While that is happening, I want to go back to Docker Hub and show you one more feature, which I have set up for this guy, is you could do something similar with Docker Hub too. You can say, hey, here's my build settings for this guy. Hey, it's bringing from the Python Flask repo. Here's the master. Unfortunately, this does not trigger a build automatically. So what I'm going to go ahead and do is just kind of show you real quick, what if I were to change this application? We go back and say here, build 2017. I'm going to go ahead and save the file and push the changes to my GitHub. OK. And I'm going to go ahead and sync those to master. Real quick, and then now basically I made a code chain that goes to my GitHub, and then one of these things should trigger a build on a Docker Hub. It doesn't do that well with the Docker Hub, but for VSTS, it will pick up the changes, it will kick off a new build, it will release it, redeploy to your application if you choose to. And in a Docker Hub, if you want to do that, it should have kicked it off. If it doesn't, you can come back and manually trigger. And once it's manually triggered, it's building the application, and then you come back here and have set up a webhook. You can set up a webhook, which is basically a publishing profile credentials for your web app. And what is this telling you is you kicked up the build, here's the webhook, and then you come to these, let's look at this Python build backup application real quick. Right? See, this one, VST has already set up the build. So if I were to look at that, it would say, hey, triggered the build, you went through the whole process. It's building an image right now because you found the change. It will push an image, and you can see the flow that is happening reactively, which is fantastic. While that's happening, let me go back here and try and open up another portal to show you the webhook that we created for Docker Hub. Great, 15 minutes. OK. So here, the build is done. The job is done. And then soon it will start and do and release that build to the web app. And then we should have our changes that we pushed into the production site from that point. While this is happening, I'm going to go search for the backup site. And to set up the same CI with Docker Hub, the point that I was making there is you come back here, you set up the webhook into Docker Hub, saying, here's my publishing profile, that's the username, that's the password. I'm going to delete the site, so don't bother about saving the password. And here's the site. And once that's done, once the build has been triggered and wired, you can come back to the site, and all you have to do is just set up a very simple app setting, which is right here. That says Docker enable CI, set to true. So once you enable that setting, you're telling basically this app that, hey, the Docker CI has been enabled. Look for a webhook that you've set up on the Docker Hub. Whenever the new build has come up, trigger the webhook, download the build, and deploy onto the site. Exactly the same thing that you did with VSTS, but the experience with the VSTS is more solid in a sense because it works. It triggers the build every single time, and it works seamlessly, right? So this one has been pushed and should have been released in a little bit once it's refreshed, and but you get an idea. So there's another way to basically Dockerize your applications and set up the whole CI/CD if you choose to. All right, we got 14 more minutes, and then we'll do more Q&A. A little bit on the roadmap. Before we go GA, we need to have a consistent SLA of 99.95%, which is our number one priority. We want to make sure the service that we deliver stays to the brand of Azure App Service, right? We want to have CI with ACR, Azure Container Registry, just like what we do with Docker Hub. There should be a bunch of app inside integration that Hamad's working on. Logging diagnostics, we've heard from customers that this is the priority, that we need to have much better tooling for our containers and insight into what is happening, whatnot. So that's a priority. We want to be in all public Azure regions if possible. Security perf is always a priority because, again, at the end of the day, these are containers. And any service that is entertaining containers or supporting containers, this is something they cannot afford to compromise. Because if you don't like it, it's appointing a container to some other service, right? So it's every other person who's making this bet on a container or providing this offering, they cannot compromise on that, and so we will not, right? So this is something that is the highest priority for us too. We'll be GAing sometime this year, provided I get all those devs off the Pokemon Showdown, and we will go to GA at some point. And finally, I want to talk about one customer example who's moving from Heroku. And there are tons of customers who are actually using the service. And let me give you a little bit of tidbit before we jump into the specific customer. When I started working on this project, the distribution of how people were using the containers or the Azure App Service and web app was almost 50-50%. 50% of the customer will use the built-in image and point to their GitHub or where the source is, and the 50% will bring their own containers. And since then, if I were to look at the recent numbers, that number has swung dramatically. More than 80% are bringing their own containers and distributing their code and stuff along those lines into single place and then deploy on that. And this customer is a great example of that. They were hosting on Heroku, pointing their code into GitHub, and then they started testing our platform out, and they really liked it, and they spent the time, a week or so, to train their ops and a dev team how to containerize the application and work with it, and they stuck with it, right? And then I'm pleased to say they are running 100% live on this platform, even though it's in preview, and are super happy. This customer is Entropy Works. It's one of the leading development and managed services out of UK. They are focused on Ruby on Rails, which is a workload that we never entertained ever in the last 6 years on a Windows offering, and it's something that we really target to go after. They make mobile applications, and they have a CMS called Remarkable. Some of the clients are Financial Times, the Art Fund, Global Radio, Oxford University Press, and these are the guys they make the apps and the managed services for, running in Heroku, and they are committed to migrate all of it 100% to the Azure from Heroku. But what they've done right now is just move their containerize their Remarkable application, which is Ruby on Rails, and then moved it to the Azure. And let me show you real quick their site, just in case, right here. Again, this is Ruby on Rails running on this Azure App Services. You can test it at 100% of the traffic. They've been with us for a long time. They're really happy, and it's a great testimony to the service that is still in preview, where customers are actually willing to associate their identity with our platform, which is which is very humbling and a great experience, right? Some of the things that their CEO had to say, where what they liked was basically, they liked the fact that, we manage the Docker fleet for them, right? They don't have to worry about the orchestration. We take care of the whole thing for them, right? They have now created a basic set of instruction to make this process very, very easy. How are they going to Dockerize every single client that they have and slowly start moving them to the Azure App Service once we go GA, right? So Eddie's been a great partner, and is one of the great examples of how customers are actually making the early bets on our platform. There are a variety of startups and on a single page applications and API that are hosted, not in a test perspective, but in production with our service. Unfortunately, I couldn't reach out to all of them and get the approval to talk about and whatnot, but it is like I said, it's a very humbling experience to know that people are making early bet on our platform and helping us succeed along the side. Finally, how can you learn more? All of our docs are at AKMS, Web App-Linux. We also announced Try App Service support for Linux yesterday. So if you are new to Azure, don't have Azure credit, or don't want to use the Azure credit card, you can simply go to Try App Service. Let me just click on that. And from here, I'll get to it in a little bit. You go to Try App Service and basically try the Linux offering out for free. Once you create the service, the web app using Try App Linux, you can actually log on to the Azure portal using your MSA and play with that application for 30 minutes, full access, right? There is no, you only can do this feature, that feature, but you can play with all the features that I showed you for 30 minutes or more with Try App Service for free without Azure account or credit card. All you need is MSA. Our FAQs are on, again, Linux FAQ. Then release note that our team maintains. It's a great resource to keep an eye on. Every time we release new feature, a couple of weeks, we go and update the release notes. And if you like to contribute, like I said, this is all open source. Microsoft really likes Linux in a sense. All our Docker files are here on a GitHub. Our images are on a Docker Hub. Feel free to download any of our images or blessed images, install your dependency if you choose to, and maintain it if you like, right? Or contribute to the system. And finally, provide the feedback on the user voice, because this is where this whole thing started, right? We had feedback on a user voice saying, hey, we want you guys to support Linux. Somebody started, it kept on going up to a point where my boss decided this is it, we need to invest in it, right? And we made it happen, right? So it's a great place to provide the feedback and let us know what we should be investing in it instead of us making those decisions by ourselves. Besides that, finally, a small plug about recommended sessions that are coming from my team. Again, serverless is a brother of our team and offering. There's a session coming up tomorrow where you'll learn about how do you build the business application using functions and logic apps and power apps. A really cool session by Eduardo and one of the PMs from the logic apps. They get into the business side and the use case of functions. Chris Anderson is one of the PMs on our team working on functions. He's going to be talking about day in the life of a serverless developer. It's a tech talk, I guess, in a tech talk A on a hub, something to look after. And recorded, these are the recorded sessions. They already happened. Designed for serverless success. I guess that was the one before this session in another breakout. I just did a talk on this morning when bad things happen to good apps, the Azure App Service Support Center. Something that is very close to my heart is I work on this project alongside what I do right here on Linux, but it is a good talk recording if you're interested in learning what we are doing in self-servicing our customers and letting them know when their web apps are down. Is it us versus them? If it's them, what is the reason? Is it the CPU, memory, which instance going bad? How we can fix it? Everything that happens within a minute, if you click. It shaves off hours and hours of time of troubleshooting when your app's down and whatnot. So it's an interesting one. And again, Azure Database for SQL, I think this is recorded, so it's something that I would recommend you watch too. With that said, I think that's all I have. Please do the evaluation input. Your feedback is very important, right? Do make sure to give out the suggestions, any feedback that you have, and how can we improve. That's it. We'll take questions. All right. Thank you.